Welcome to the repeat class of metabolism. Today we will do only with the tricarboxylic acid cycle, not all. So tricarboxylic acid cycle. So this was discovered by Hans Krebs long back in 1937. He received Nobel Prize after many years, in 1953, for this discovery. He was forced to leave Germany prior to World War II because he was a Jewish man. The problem of Jewish and German is there. So TCA cycle, Hans Adolf Krebs, 1937 born, and he studies oxygen consumption in Fijian breast muscle. He did a lot of work in that Fijian breast muscle. Location is in the mitochondrial matrix. For everything, mitochondrial matrix is the chief nodal point to do everything. So, as the mother donated mitochondria to us, so mitochondria synthesizes a lot of energy for all of us. In close proximity to the electronic transport chain, this mitochondrial matrix will be going on activated. 60 to 70% of the ATP is synthesized here. So TCA, tricarboxylic acid, the name is used because at the outside, the cycle is participated by the tricarboxylic acids. That's why the name was given. Citric acid cycle or tricarboxylic acid cycle essentially involves the oxidation of Acetyl-CoA to carbon dioxide and water. The main source is Acetyl-CoA, and that will be oxidized to carbon dioxide and water. So TCA is central metabolic pathway. So pyruvate from the glycolysis will be converted to acetyl-CoA, and that will enter the Krebs citric acid cycle. And reducing equivalents were given by that, and those reducing equivalents will be participating in the oxidative phosphorylation to give ATP. And amino acids will enter the Krebs citric acid cycle. It is the central metabolic pathway for everything and anything. The fats, amino acids, carbohydrates, all the things will enter this and finally get converted to ATP. So amino acids will enter the Krebs citric acid cycle and get out of it. And fatty acids will enter to give acetyl-CoA. And acetyl-CoA will again get converted into fatty acids. So in the cytosol, pyruvate will be there, and in the mitochondria, aerobic TCA cycle will be taking place. That is the only thing you have to remember. So remember, glycogen will be broken down into glucose by glycogenolysis. You know pretty well, one glycogen moiety is composed of about 56,000 units of glucose. So homopolysaccharide, 2 units of glucose. So the excess glucose is packed up into glycogen in the liver and the muscle. The liver will have more amount of glycogen than the muscle. So when the emergency comes, the liver glycogen will be broken down by glycogenolysis into glucose. And that glucose will enter the glycolysis and produce pyruvate. And this pyruvate will go down into the conversion of acetyl-CoA. So this acetyl-CoA participates in steroidogenesis and fatty acid synthesis, and TCA cycle continues. It produces ketone bodies, and the protein acetylation also will be taking place through acetyl-CoA. So the free fatty acids will be participating in the beta oxidation to give acetyl-CoA, and triglycerides will be converted by lipolysis into free fatty acids and beta oxidation acetyl-CoA. And protein by proteolysis broken down into simple amino acids, and by deamination and oxidation, acetyl-CoA is formed. These are all the various interlinking processes by which ultimately you should get a lot of acetyl-CoA. And this acetyl-CoA will take part in steroidogenesis and fatty acid synthesis, PCA cycle, ketone body synthesis, protein acetylation. So this is the central figure of PCA cycle. So oxaloacetate is the first one, first compound, and this oxaloacetate, by the action of citrate synthase, will be converted to citrate, and this citrate will be converted to isocitrate by the action of 2-equanitase, and isocitrate will be converted into alpha-ketoglutarate by 3-isocitrate dehydrogenase, and then alpha-ketoglutarate will be converted into Succinyl-CoA by the action of alpha-ketoglutarate dehydrogenase, and Succinyl-CoA will be converted into Succinate, and 1 GTP is formed in GDP, and the enzyme is 12-Succinyl-CoA synthase, and this Succinate will be converted into Fumarate by 6-Succinate dehydrogenase, and this Fumarate will be converted to Malate by enzyme Fumarase, and then Malate will be converted to Oxaloacetate by Malate dehydrogenase, and there NADH is produced, and another NADH is produced during conversion of alpha-ketoglutarate to Succinyl-CoA. So NADH, and another NADH isocitrate to alpha-ketoglutarate. So large amounts of NADH is produced in this citric acid cycle. So regulation. For every cycle there should be a regulation. If you simply say the cycle should have pedal, accelerate speed, and it should have brakes, left and right, front wheel and back wheel brakes, and free wheel. So 4 brakes. So there are regulations. 3 regulatory enzymes: citrate synthase, isocitrate dehydrogenase, alpha-ketoglutarate dehydrogenase. Only 3 things. So simple. Only these things we ask in the examination. Not complicated, not confusing questions. So the 3 regulatory enzymes that regulate the DCA cycle are citrate synthase, isocitrate dehydrogenase, alpha-ketoglutarate dehydrogenase. You just read once, you can make it up in your brain. So requirement of oxygen is most important by DCA cycle. There is no direct participation of oxygen in DCA cycle. Only it will operate under aerobic conditions. This is due to NAD and FAD are required for the operation of the cycle and can be regenerated in the respiratory chain only in the presence of oxygen. Therefore, citric acid cycle is strictly aerobic. So formation of citrate. So oxaloacetate is the most important one. The citrate synthase and acetyl-CoA will participate and then give citrate. So oxaloacetate will give citrate. And citrate is acted upon by equanitase. It's a hydrolytic reaction. One water molecule will be given and isocitrate will be formed. Isocitrate will be converted to alpha-ketoglutarate by isocitrate dehydrogenase. Wherever dehydrogenase is there, one NAD will be converted to NADH. So this is most important, NADH. Alpha-ketoglutarate will be converted into Succinyl-CoA by the participation of alpha-ketoglutarate dehydrogenase complex. So alpha-KDC complex we call it as multi-enzyme complex. We have PDC complex, alpha-KDC complex, and one more. Multi-enzyme complexes are many in biochemistry. In good olden days, they used to give it as a short notes. But nowadays, we are not putting you to so much trouble. But anyhow, it's better to have a general idea. So alpha-ketoglutarate will be converted into Succinyl-CoA by the effect of alpha-ketoglutarate dehydrogenase complex. And one NAD dependent reaction will be converted to NADH and H+. So Succinyl-CoA will be converted to Succinate by the participation of Succinyl-CoA synthase. And one ADP will be converted to one ATP, one GDP to participating to get converted to GDP. And one GDP will be degraded down to one GDP. So succinate will be converted to fumarate by the participation of succinate dehydrogenase. And FAD will be converted to FADH2. So fumarate will be converted to malate by hydration of fumarate to malate. It's a hydration reaction participation of H2O. So oxidation of malate to oxaloacetate. Coming back to the original step. So malate will be converted to oxaloacetate by participation of malate dehydrogenase. NAD will be converted to NADH and H+. Inhibitors. For every good thing or bad thing, there may be accelerators, there may be inhibitors. That's common in this world. So important enzymes of TCA cycle inhibited by the inhibitors. For every enzyme, there is an inhibitor, respective inhibitor. Aconitase. Aconitase is an enzyme that will be blocked by, inhibited by fluoroacetate. It's a non-competitive inhibition. The alpha-ketoglutarate dehydrogenase enzyme is inhibited non-competitively by arsenic. So remember, these are the two enzymes, aconitase and alpha-ketoglutarate dehydrogenase. And both of them have non-competitive inhibitors. Fluoroacetate is a non-competitive inhibitor. Arsenite is a non-competitive inhibitor. And the third thing is succinate dehydrogenase, that is having a competitive inhibitor, malate. So that is the only competitive inhibitor, malate. Other two things are non-competitive inhibitors. So remember, fluorine and arsenic are two great dangerous poisons for the production of energy. So what will happen if our drinking water is having large amounts of fluorine? We know about the endemic fluorosis, Nalgonda, Nalgonda and Puttapatti. These are the areas where the drinking water will be having large amounts of fluorine. So wherever we go deeper and deeper for the borewell, the deeper strata of the earth will contain the stones, and these stones will be mostly crystalline. You know pretty well about the fluorine, chlorine, bromine, iodine. These are the halogens. Out of all this, fluorine is the most powerful acid, hydrofluoric acid. And the second most powerful and active is the bromine. And next most powerful thing is chlorine. And the least active is iodine. So when fluorine, hydrofluoric acid, goes deeper and deeper into the earth strata and reacts with the stone, there is a lot of fluorine incorporated into the stone. And these stones will be bored down by our borewell people, and they will go beyond that strata. Thereby, even though what we are getting, but that water is readily soluble with the fluorine. And finally, we are getting only fluorine rich water. So if we drink large amounts of fluorine contaminated water, what will happen? The aconitase enzyme will be inhibited. It's a non-competitive inhibition. We cannot get any ATP. So the people will be eating large amounts of food, be going for work, but they cannot be able to do any work. They sit under the tree and take rest. If anybody asks, they will ask, I'm very weak, I cannot do any work. I cannot do plumbing. I cannot do reaping. I cannot do harvesting. Nothing can be done. Because they are very weak, because there is no ATP. Understood? So remember, endemic areas of fluoride is most dangerous. So what God Almighty or nature we call it had done an alternative mechanism, and the thing that defluoridates is turmeric. So large amounts of turmeric trees will be seen growing without any effort in highly endemic areas of fluoride, high fluoride water areas. So if the people are particular enough to collect large amounts of turmeric, not turmeric, it's not turmeric, Chintapandu. What do you call that Chintapandu? Turmeric is possible. Chintapandu is, I'll tell it. So Chintapandu is very rich in the areas where there is a lot of fluoride rich water. So when we utilize Chintapandu to prepare any rasam or sambar or mix it with any curries, so this fluoridation will be prevented. So this is the areas of endemic areas of fluoride rich areas. The people will get away with fluoroacetate non-compatible inhibitor, and econitase will be saved. And the other thing is alpha-ketoglutarate dehydrogenase. For this we got arsenic. For this we don't have any escaping mechanism. Arsenic is very much present in all the earth crust. So we can't just prevent it just by the arsenic dioxide, arsenic pentoxide. All these things are present in the soil. And this arsenic is sometimes given as a poison. So some people got a bad opinion about our life. So they will try to willfully poison us by putting arsenic. And this arsenic is known as Illipashanam. By presence of arsenic in the food, there will be a particular smell like onion smell, strong onion smell. The same good olden days, the kings, when somebody invited them for a party, happy get together party, they used to take along with them 2-3 dogs. What for? The dogs know better about the smell than the human beings. So the olfactory lobe of the dog is wider than that of the human beings. So the dogs used to first sniff, and when it sniffed the presence of arsenic, then the dogs used to run away. Then the fellow also used to leave the dining hall, and the fellow who invited him for the food should be killed, isn't it? The great people will do only that. So not know that the dog is wrong or right, but these are the things that once upon a time we used to practice. Alpha-ketoglutarate dehydrogenase or magnesium complex is non-competitively inhibited by the arsenic dioxide or arsenic pentoxide. So the other thing is succinate dehydrogenase. So succinate dehydrogenase is competitively inhibited by malate. Okay. So these are the 3 inhibitors only. You need not worry about all these stories that I told. We don't ask all those. We ask only these 3 enzymes, 3 inhibitors. So, okay. So these are the control points. So pyruvate going to Acetyl-CoA. All this thing is only for the synthesis of ATP. Suppose if we have enough amount of ATP, why should we work? So we got enough amounts of stores of energy. So in the first step itself, it will be inhibited. So suppose a lot of food is prepared and kept ready in the house, for a long range use, sweets and hots and other things. Then even if you get 15 or 16 people extra for that day, that's just, you need not worry. So the mother will go into the kitchen room and say, okay, it doesn't matter. I prepared for 50 and extra for another 15. So I need not prepare anything extra. Even 50 plus 15, 65 people comes, we can say, we can serve without denying. So these are good old days. Now we are not worried. We can just place an order and within 15 minutes, big packets will come somewhere. What is that? I do not know. Some mechanism. Okay. So pyruvate will be converted to acetyl-CoA, and this conversion is inhibited by the presence of large amounts of ATP in the body. And large amounts of acetyl-CoA in the body is there. And why the pyruvate should undergo the transformation of citrate, it's not needed. So large amounts of ATP, large amounts of NADH, large amounts of Succinyl-CoA, large amounts of citrate. That is and stage inhibitors. When everything is there, why should it work there? So it will just stop there. And then citrate should be converted into isocitrate. And isocitrate should be converted into alpha-ketoglutarate, and that will be inhibited by presence of enough amounts of ATP and NADH and stimulated by ADP and NAD+. So these are the things that accelerate the production of alpha-ketoglutarate. And alpha-ketoglutarate will be converted to Succinyl-CoA if large amounts of ATP and NADH and Succinyl-CoA are present. It will be just, that step will not continue. It will stop there. The Succinyl-CoA will be converted to succinate. The succinate will be converted to fumarate. And the fumarate will be converted to malate. And malate will be going into oxaloacetate. Okay. So this is the cycle, and these are the importance of various steps and the control points and inhibition of the reactions and steps requiring electron acceptor. It's the most important. So steps requiring electron acceptor, either NAD plus or FAD, is most important. So you have to remember that. So where we require electron acceptor, either NAD or FAD, where pyruvate to acetyl-CoA conversion and isocitrate to alpha-ketoglutarate conversion and succinate to fumarate conversion and malate to oxaloacetate conversion. In all these four places, electron acceptor in the form of NAD plus or FAD is most important. Okay, so this is also frequently asked. If most of you answers all the things and nothing is left for us to ask, finally we will ask you like this. Okay, nothing more. Only 6 points, that's all. Fingertips you can learn. So amphibolic nature of TCA cycle. All the things will enter into the TCA cycle. Carbohydrates, fatty acids, amino acids, all will be entering it. It's the ultimate common pathway for production of energy. Whatever we eat, whether it is carbohydrates, or fatty acids, or amino acids, everything will enter TCA cycle, and the common entry point is acetyl-CoA. And from there it will grow NADH and FADH2, and from them ATP is produced. And finally, GTP also will be here. So biosynthesis, so the acetyl-CoA will be carbohydrates will be converted to pyruvate, and even proteins also will be converted into pyruvate. You know about the glucogenic amino acids, all these things. So fatty acids will be converted into acetyl-CoA, and the acetyl-CoA will be going into citrate, and the citrate will go into fatty acids, and citrate will be supplied through the height. So the citrate will be supplied by the glutamate, and vice versa, the citrate will be converted to glutamate also. And most of the proteins will be converted into glutamate, and the glutamate will be converted back to proteins. So two carbon dioxide molecules will be given out in the TCA cycle, and that will be converted to malate. And interconversion of malate to malate is most important. And malate will be converted back to carbohydrate, and the aspartate will be going into the TCA cycle, and it will be converted back to aspartate, and proteins synthesis will be taking place by aspartate. So, in the energy production, the amphibolic nature of TCA cycle is proved, and in biosynthesis, the amphibolic nature of the TCA cycle is established. So, important anabolic reactions of TCA cycle. Just you have to remember, oxaloacetate is precursor for aspartate. Just now we have seen. Alpha-ketoglutarate can be transaminated to glutamate. Succinyl-CoA is used for synthesis of heme. That's the starting material for heme biosynthesis. Succinyl-CoA. So that's why we are depending on carbohydrate diet for the synthesis of heme. So whenever a woman is establishing that she is pregnant, so what the ultimate step the mother in the house will take place about the daughter or daughter-in-law. So most of the time, only the mother-in-law will be there. By the time she knows about the pregnant state of the daughter-in-law, so immediately she will prepare paramannam, sweet rice. So what the sweet rice contains? Just carbohydrate, rice, and lot of milk, and then lot of sugar or jaggery. In rich people's house there is jaggery and sugar, and in poor people's house there is somehow they will try to get jaggery. Isn't it? So Succinyl-CoA will be synthesized from the high carbohydrate right through the glycolate pathway, and finally the Succinyl-CoA will be utilized for the synthesis of heme. You know pretty well the heme biosynthesis, various steps and various types of heme molecules will be formed in life, and it is just about to get delivered. And once it is delivered, adult hemoglobin, all these things will be pretty well on heme biosynthesis. So remember, Succinyl-CoA is used for the synthesis of heme. All of us had the benefit of our synthesis of heme in our pediatric life, in our intrauterine life, in our even adult life, only by the synthesis of Succinyl-CoA through the carbohydrate glycolate path. And mitochondrial citrate is transported to cytoplasm, and it's cleaved into acetyl-CoA to provide substrate for the fatty acid synthesis. This is one wonderful magic. So mitochondrial citrate is transported to cytoplasm, and it's cleaved into acetyl-CoA to provide a substrate for the fatty acid synthesis. All these things you have to read with interest and with a view to apply. So citric acid cycle, TCA cycle, or Kreb cycle, energetics. 2 acetyl-CoA from 2 pyruvate will give rise to 1 NADH, 1 FADH, 1 GTP. And you know 1 NADH is equal to 2.5 ATP, 1 FADH is equal to 1.5 ATP, and 1 GTP is equal to 1 ATP. So generation of ATP in citric acid cycle is the total calculation. number of ATP generated by oxidation of 3 NADH. So we got 7.5. So 2.5 into 3, 7.5. The number of ATP generated by oxidation of ADH. So 1.5 ATP, that is ultimately left. The number of ATP generated from GTP, only 1. So net together 7.5 plus 1.5 plus 1, that is 10. For 2 molecules, we have 20 ATP. So if you can say that only 10 ATP is there, you can just apply it, no problem. But if you remind you that there are 2 molecules, then you have to correct yourself and say 20 ATP. So applied aspects of TCS I get. So mitochondrial encephalopathy occurs due to fumarate deficiency. So mitochondrial encephalopathy is a mitochondrially transmitted disease, and that is due to the fumarate deficiency. So mitochondrial myopathy affecting both the skeletal muscles and brain. The child will be just like a vegetative structure, and he can do no work, no thinking, and cannot move. He will be just lying like that for some time, and after that he will die. So mitochondrial encephalopathy, we wish that nobody should get, and we should get the healthy mitochondria from the mother, maternal mitochondria. As long as it is healthy, we are healthy. Otherwise, we have to get into your YouTube and click and see the mitochondrial encephalopathy, fumarate deficiency. So mitochondrial myopathy affecting the skeletal muscles and brain. You can see a large number of cases in the YouTube. So please do it as an exercise in your house, since you can explore the knowledge from your YouTube or any other source, or by reading the textbook of pediatrics, or by reading the textbook of genetics. All the things, everything is open for learning. Nobody asked you not to see the other books. Okay, so hope all of you will get benefited by this. We will go into the more aspects of this, applied aspects of TCS. Thank you.